Alright, we're going to do problem 10 from chapter 1 of Rosenlicht's Introduction to Analysis. So, it's some questions about functions that are fairly simple. So the first one, part A, we're asking how many functions are there from a non-empty set S into the empty set. So let me focus the camera for a second. Okay, and the answer to A is 0, and kind of the reason behind. Remember, a function it is a rule which assigns to each x in S an element of the empty set. So if we had a function, say our function f is from S to the empty set, then for every x in S we need an element of the empty set, but there are no elements of the empty set, so there can't be a function. So that's why there's 0 functions. And we use the fact that S is non-empty here to say that there has to be some x in S, and yeah. Otherwise, we have this vacuous case, which is in part B. So how many functions are there from the empty set into an arbitrary set S? And here the answer is 1, and it's the empty function. And the idea of the empty function is, we need to assign every element of the empty set an element of an arbitrary set S. Well, there's only one way to do that, and because there's no element in here, you just don't assign anything to anything, and that's the function. And notice this is why we need non-empty in part A, because the empty set to itself, there is the empty function there. C, we want to show that the notion the set of xi, where xi is an I, implicitly involves the notion of function. And the idea here is so we're thinking of all of our xi's. So let's think of our xi's are in some set S, and this is for every I in I. Then the way we can think of this is a function from I into the so-called power set of S. That is the set of subsets of S. And the idea is for every little I in I, we have that f of I is equal to x sub I. Because x sub I, this should be subset, not elements of. Every x sub I is a subset of S, therefore it's an element of the power set of S. And so that's the implicit notion of function that is involved in this notation. Alright, thanks for watching.